A few words about me. I'm Tomasz Konieczny. I currently work for RAW as senior QA engineer. And during my earlier career as a QA, I worked on many very different things, but most of them were related to test automation. I also worked for over a year as a DevOps engineer, so I not only designed test environments, I also worked at production ones. And today's presentation will be connected to both of these areas, I mean test automation and infrastructure. Let's start with a basic question. Why do we execute end-to-end regression tests? Or maybe why do we even execute regression tests? Because during the development of new functionalities, it's possible that we'll introduce bugs to already finished ones. And regression tests are intended to identify these possible problems. And why do we need high-level regression tests? Because if we have low-level ones and one of these tests is red, it's quite obvious. I mean, something is not working, the application or the test itself. But if all of these low-level tests are green, it only means that the tests are green. And that's why we need high-level tests like end-to-end tests, for example. But there is one serious problem related to them, I mean time, because it takes a really long time to execute regression tests. And we have to repeat it again and again during development process. So not only QAs or development team have to spend a lot of time on the execution, but it also means that the feedback time is really high. I mean, we have to wait a very long time to get the results, to be sure if the application is working correctly or we have to fix some bugs. And solution for that is automation. If we automate something that's repetitive, like for example regression tests that have to be repeated again and again during development process, then we can definitely save time on the test execution. But second part is that it also speeds up the feedback time. I mean, automated regression tests are way faster than manual ones. And we can get feedback faster. We will know earlier in development process that something is not working. We'll be able to fix that. And the cost of fixing bugs will be lower. And we also have a better predictability in this case. So everything here is about execution speed. I mean, if we have faster execution, it means that we will have faster feedback. We will know everything earlier in development process. And also faster feedback means faster delivery, that we'll be able to actually deliver faster. We will deliver business value faster, and that should be our goal. I mean, it's all about delivering business value. So that's why we automate tests. We can execute them way faster than manual ones, for example, in a few minutes instead of even hours. If we have some automated build process, we can include this automated tests in, for example, build pipeline, and we will know very fast what's the state of the application. So, for example, every pull request, every repository push, the test will be run, and we will get our feedback. Then, if we have significant test coverage, then we can even extend continuous integration with CD, continuous delivery, or even continuous deployment. Because we have tests automated, we can easily run them, check what's the application status, if it's working, and we can make decisions based on that. It's great, isn't it? Well, that's where the problem appears. I mean, we develop application, we create more and more tests, and the test set grows. It means that the execution time increases again. So it's 10 minutes, 30 minutes, maybe in hours. And that's the time we have to wait for to get the results of our tests, even if they are automated, even if manual ones will last like 10 times longer, maybe. So basically, we have the same problem again. Tests aren't fast anymore. I will show you the example here because it's better to show and based on examples, specific cases. So let's assume we have 500 Selenium tests. Each of them lasts 20 seconds. So we need almost 3 hours to execute this whole set. And it's already automated. We can speed it up easily. What can we do in this case? How to solve this specific problem? Well, we may think about tested redesign. Maybe we don't need to execute whole complete test set in every case. Maybe we can execute this full set only in specific cases at master branch, or in develop branch, or maybe in specific pull requests. And in other cases, we may use some limited test cases to check just specific functionality, or to run just smoke tests that will allow us to get feedback earlier. And that may have some benefits in this case, but still we won't get full feedback. And I think we should think about it. Maybe we should think more about test pyramid. Maybe we can introduce some low-level tests instead of all of these high-level ones. I mean, we still need high-level tests, but maybe we can replace some of them with, for example, some API tests. Maybe we don't need Selenium everywhere. Or maybe less frequent builds. Instead of running tests every pull request, every repository push, we can run tests like every few hours at more important branches, or every specific pull request. That can also save us some time. We will get the basic feedback a few times a day. Maybe that isn't that bad. Maybe we should add some compute resources. So we will add, for example, a few instances, a few virtual machines. We will run tests at, for example, 4 browser instances for virtual machines, and we will speed test execution like 4 times. So we will reduce it from almost 3 hours to like 45 minutes maybe. But is it fast enough? 45 minutes, I think it's still quite a long time. And also, in this case, we won't just need like 4 instances for the virtual machines. We will need 4 multiplied by number of concurrent builds, and sometimes we will have like maybe 5 builds that we have to run. We will need like 20 virtual machines. That's a lot of resources. And sometimes we won't have any builds, so it will be quite expensive to keep all these instances. And it's possible to solve it with use of, for example, clusters. I implemented something like that a few years ago. I used Kubernetes cluster to dynamically scale the test infrastructure. And it worked fine. I mean, it wasn't that bad, but the problem was that it was quite complex, both to implement and to maintain. And I think that it's definitely not something that we want in case of infrastructure, if we don't need it at least. So my answer to all of these questions will be just no. I mean, these aren't the solutions. These are like workarounds, and I would say very basic. And in my opinion, the only real solution currently is to use cloud services, but not like VMs again and again. I mean, it's not the solution at all. I mean, we should use cloud properly. So not, for example, like 4 or 8 VMs in cloud that will speed up test execution like maybe 8 times. It's nothing. I mean, I'm saying like hundreds of parallel instances. Because we have 500 tests, we can really run it concurrently. So our goal definitely should be a parallel test execution. If you run 500 tests in parallel, then we can really speed it up. So the best way to achieve it, in my opinion, is to use serverless services. So basically, we have code. We just want to execute some code, get the results, and that's all we want to think about. I mean, we deploy tests, run it, and then we get the results. Idea is very simple, how to implement it. I use AWS Lambda to implement a proof of concept I will show you. I will show you a complete code of this POC. And if you don't know AWS Lambda, it's a function service at AWS. It's probably possible to use any cloud provider that has similar services. I just use AWS most of the time, so that's why I used it. Lambda is a function service. It means that it's possible to deploy code in one of supported languages and trigger it and get results. Just a very simple thing. So we can deploy code in Python, Node, Java, C#, and probably some other languages also. And that's what we need in this case. But what's great about Lambda is that it allows us to implement this parallel test execution really easily. Because the initial concurrency of Lambda is from 500 to 3,000 concurrent functions, depending on the AWS region. So that's exactly what we need. We can deploy code, and just after that, we can make 500 requests to get specific results. And what's also great is that like a year or maybe 2 years ago, AWS allowed to use something named Lambda Layers. And Lambda Layers allows us to create custom runtime environments because we not only have code of our tests, we also have some libraries, external dependencies, maybe some binaries that we need to run there. So in case of Selenium, it will be driver, for example, Chrome driver. It will be browser like Chrome or Chromium, for example. And we also need that. And Lambda Layers allows us to put all of these dependencies that we have and deploy it separately, create custom runtime environment where we'll be able to execute our code. So in this case, to really simplify all of these things, I mean management of infrastructure, I used Serverless framework. Serverless framework is a great tool that implements infrastructure as code concept. It means that we can just put our description of infrastructure in our repository. We can easily create, deploy it, and it will do everything for us if we have it configured. I used it with AWS Lambda. So let's start with implementation part. Let's start with Lambda Layers, so our dependencies. In this case, we will need, as I said earlier, Chrome and Chrome driver. In this case, I used Python 3.7, so we also need Selenium libraries for Python in this case. So let's create a Lambda Layers directory. There we will put everything related to Lambda Layers or our runtime. So we have Chrome directory where we have 2 binaries. It's Chrome driver and Chromium browser. We also have a Selenium directory where we have all of these Python dependencies, libraries, etc. related to Selenium. So basically all our development dependencies. It's possible to deploy it with code, but it's better to put it in layers so we don't have to upload it every time we change a single line of code. So in this case, just pip install to the specific directory. We have our dependencies here. And also there is one more file, serverless YAML. That's the description of our infrastructure, in this case of our layers. So a service, that's our service name. Lambda Selenium layer, because here we have everything related to this test runner. Provider, that's the configuration of our provider, so AWS. Runtime, we will use Python 3.7. That's available at AWS Lambda. Region, again, AWS region, so Europe West 1. And timeout for our function, 30 seconds will be enough here because every test is like 20 seconds, just to simplify it a bit. We also have layers part. So here we have description of our layers. So Selenium layer, path Selenium, that's the directory where we will have our libraries. Compatible runtimes, Python 3.7, because we are using it. Also, the second one, Chrome. Here we will have Chrome browser and Chrome driver. Again, path Chrome, that's the directory. And that's a whole description of our layers. These are the dependencies we will have. And it was really easy, like half a year ago, because it was possible to just fit all of these binaries to Lambda layers. But there are some limitations in case of Lambda. We can upload only 50 megs of directly of sources, or we can upload more, like 250 megs in Lambda layers. But current versions of Chrome browser are heavier than this, so we can't fit Chrome browser directly anymore. We have to use some workarounds. How Lambda Layers works is that during the first execution, it copies the content of Lambda Layers to the opt directory in Lambda, so we can use it from there. We have all of these libraries or binaries available at opt directory. But here we have this limit. So what can we do? We can deploy layers with compressed binaries to reduce this size, and then we can decompress it at Lambda runtime. because we have TMP directory where we can store up to 512 megs of content. So we can extract this compressed binary to this directory to be able to use it as in other cases. But because it will be executed every time we run our function, or at least it may be executed every time we run our function, we have to choose our compression algorithm wisely. I mean, we don't care how long it will take to compress this binary, because we will do it quite rarely every time we update browser, so like every few weeks. We don't care about compression time. But in our case, decompression time is really important because it has to be really fast if we want to execute it a Lambda startup. So I found two algorithms that are both efficient if we think about the file size, and also they are very fast to decompress. One of these is TaraXZ. The second one is Brotli. Brotli is even better. That's the algorithm developed by Google for their internal needs. And it's great to use, but not in Python. I used it when I implemented the same thing in Node, because it was a library available for Node. In the case of Python, it's not that easy. So in this case, I used XZ. In this case. So here we have the example of code that we'll have to run every time we run our function before we actually will have browser available. So just the basic extract dependency method that basically extracts a file from opt directory. So we can pass any file name here to the TMP directory. So we will have this binary available when we execute our function. So now we have to deploy or create our tests, because we not only need dependencies, we also need some tests to run. So let's create the test runner function. That's our actual Lambda function. So directory Lambda test runner, because it's probably one of the best descriptions. And here we have two files. Handler is a file that will be executed at Lambda function. So just to simplify this proof of concept, it's just a single file. In normal case, we will put every test that we have here. And also second one is serverless YAML. That's the definition of our infrastructure for this function. Let's start with serverless YAML. We have, again, service. That's the name of this function. We have provider. So in this case, again, AWS, Python 3.7, region. We have two parameters that are really important here. So memory size, that's our RAM size, so 1 gig of RAM. We also have a function timeout. 30 seconds will be enough to execute this test that we have. And definition of our function, so Lambda runner function, handler, so that's the file that will be executed if we trigger this function. So Lambda runner method from handler file. We also have event that will trigger this, and we have our layers that will be included in this function. So it will automatically add all of the contents that's in this layers to our function. We'll be able to use it at runtime. So in this case, Selenium layer and Chrome layer. Okay, but start with implementation of our tests. So it's most of it is really standard Python Selenium test. I will describe it now. So we have import of WebDriver from Selenium package. We have JSON that will be used to prepare the response, and then we have our function that will be triggered with when we trigger Lambda. So we have this extract dependency. We have to extract this Chrome TarXZ file, so we will have a Chrome binary available. So it will extract it from opt directory to TMP. We will have a Chrome binary there. Then very basic test results to just track if it's fine. Options, browser options, so binary location in this case is this TMP Chromium, that's where we extracted this one. A few Selenium arguments, and they are really important in the case of Lambda, because if we skip any of them, it won't work. So you need headless parameter to run a browser headlessly without graphical user interface. We need to disable dev.shm, that's the Linux shared mem. It's required to be able to use headless mode. We also need, or at least it's better to use single process just from performance reasons. And no sandbox, the same. We don't need sandbox in this case, it's just a function. Also, driver options. So we load this. We have Chrome driver at opt directory. It's not that big. We don't have to compress it at extract. We are able to just use layers here. Then we will have actual tests. I skipped this part because everyone probably knows how to write a test in Selenium. It's not really important here. We can print anything to std out. It will be saved in Lambda logs, so very useful thing. We can also print events, so that's the parameters. And then after that execution, we can pass any response to the runner. I very simplified this part because it's, again, something quite standard. We just return the results to the runner. And now the runner part, because we are able to trigger Lambda function in many ways. You can just make an request with any tool, like, for example, a curl or any other tool that allows us to make HTTP requests. But it's definitely easier to use it in other form. I mean, to implement some runner that will run these tests. So again, very simplified. Bottle free, that's the official AWS SDK. So that's what I used. ArcParse just for passing arguments. YAML and JSON and base64 for parsing the results, creating requests, etc. And what's important here, concurrent futures and threadful executor. That's Python functionality that allows us to trigger or to make several requests at the same time. So here we have our parameters. Again, it's a proof of concept, so really simplified, just the ability to run the more detailed logs, the ability to run it sequentially, so we can compare the execution time, very basic ones. Then we load our test set. So again, very simplified implementation. We have just a YAML file, test set YAML, where we can store our test set. So the runner will know what test we want to run. And in this case, we'll have, for example, every test tag, like for example, test 1, test 2, test 3. And runner will pass these arguments to the specific Lambda function. So we'll be able to use specific Lambda to just run one of these tests. And so that's the goal here. Data dict, and that's the dictionary for our build state, so we can easily track the execution. Is the test scheduled? Is it executed? What's the result? What's the output? So it's added to every specific test case ID, so we can easily track this one. Then the bottle-free part, so AWS credentials, Lambda, so that's the type of the service we'll use, region, AWS access keys, API keys, etc. Then we have the method invoke test that will actually run this specific test. We pass test case ID here, so it will run just this one specific test. We set this test as scheduled, so that's why we need this dictionary. Then we invoke our function, that's the actual Lambda invocation. So we have client invoke here, function name, that's the name of our Lambda function. We have invocation type request response, and that one is just for proof of concept to check if it's working, because in case of real implementation we'll have to use event. Request response is great because we can just make a request and it will wait for the response. We will get the response directly. So it really simplified the implementation, but I will speak later how to use event, why it's needed. Also payload, that's the data that we will pass to our function. In this case, we will pass a specific test case ID. So we invoke Lambda, we pass test case ID, it will execute just this specific test that we want. Every Lambda will include whole code of our test, so it's possible to execute any of the tests there. We just want to execute one Lambda. Then, after the execution is finished, we marked the specific test case as executed. We save the output from our Lambda response. We parse it so it's more human readable. And we save the results if the test failed or passed. And now the executor part, so how we invoke this invoke test method. So if it's not in sequential mode, we will use the threadful executor functionality in Python. We set the max workers to 500, so that's enough in our case because we have 500 tests. It will run 500 threads locally, and every thread will invoke this Lambda function. So it takes like maybe a second to invoke all of them. It's really fast. And after some time, we will get results. In case if we have sequential mode enabled, it will just run it sequentially. And also the last part of the runner, the report, again, very simplified because it's just a proof of concept and it's better to show how it works this way. So we check how many tests passed, how many tests failed, and then we parse the results and print it in correct order because different functions may finish in different order, so we definitely want a specific order of our test cases, so that's why we parse it again and print. So I ran this runner with just 5 tests because output is huge otherwise. So we have 5 test cases that are scheduled. Then we can see that they are executed. Order is different here because every Lambda finished in different time. We have report with status of these tests. All of these tests passed. And we have summary. So 5 passed test cases, 0 failed. And because I added time comment in CLI, we have also execution time in output. So we can see that total execution time is 25 seconds in this case. But if we check user and sys, that will show us that we actually haven't used any resources at the host side because everything was executed in these Lambda functions. But I told you that we have 500 Selenium tests, so then I ran just 5. What's the execution time of whole complete test set? It's about 30 seconds. So we reduced execution times from almost 3 hours to about 30 seconds, including the deployment time of infrastructure. Not the Lambda layers because it takes some time to upload this 200 megabytes. But if we want to just deploy our source code of our tests, if we change something, we run it, it takes about 30 seconds. So it's really way faster than the standard solutions that were used earlier. But we just ran 500 instances. What's the execution cost? About 17 cents. So if we think about it, that we have feedback way faster, we don't have to wait a few hours to get the results. Whole development team waiting for the results, well, we don't have this anymore. I think this cost is really low. We can run it very frequently. We'll be able to get feedback earlier in the development process. We will have continuous feedback in the case of our tests with very low cost. And what's even better is this proof of concept is a few hundred lines of code. It's really simple to implement. But there are still some limitations. This is a proof of concept, so it was intentional in some parts. I will describe what are the limitations and how to extend it to implement something production ready. I already did that. I implemented production ready tool, so I will show you the concepts. It's too complex to show whole code, describe it, etc. During presentation, but you will have the general idea how it works. So the first limitation is invocation type. I told you earlier that we will use request response as invocation type for Lambda. And the limitation here is if we use request response, it means it will wait for the response. And in this case, API gateway is used internally. The max execution time for API gateway is 30 seconds. So that's the max test execution time that we are able to use in this specific case. In this example, the test lasts about 20 seconds each, so it was fine to use request response. But I will show you what can we do. So first thing is that we have to change invocation type to event. In this case, we won't get the results directly from Lambda function. So that's not that easy to just make API call and get the result. We will need some additional test state storage. So in this case, the only thing that runner will do is to trigger Lambda, but Lambda won't return any results directly to the runner. So we need additional database as test storage. So everything will be executed at Lambda side. After Lambda finishes the execution, it will post the results to the database. And runner will be checking the results in the database. In this case, we'll be able to extend the execution time to up to 15 minutes. And I think that's enough for almost all cases that we use in case of end-to-end tests. 15 minutes should be enough. So it's really easy to use, for example, DynamoDB. Because, again, we don't have to think about infrastructure. We can just add the data to the database. The runner will be just checking the state of specific test. And after the Lambda finishes the execution, it will just post the results there. Runner will download it. A bit more complex implementation, but it's like 100 lines of code, maybe not something difficult to implement. How I extended this proof of concept in production tool. I also used a few other AWS services. So first of them is CloudWatch. That's the service that allows us to get logs from Lambda function. So we have detailed low-level logs from Lambda execution, very useful in case of debugging. We also have DynamoDB database, so it allows us to post any results or any data that we need from the test execution to the database. Then the runner can easily download it. We can easily store this execution state there. We also used an S3 bucket. That's the simple storage service. It allows to upload any file and store it easily. So we have artifact storage for our builds. Every time something fails, complete logs are saved there. So we have, for example, screenshots. In case of failure, we have HTTP archive, so we can check every specific request that was done in case of our application. And also we have additional reports that we can upload there, that Lambda is uploading there during the execution. Again, very simple to use because we can configure everything, every specific service that we use in our serverless YAML config. So we can configure S3 there, we can create bucket there, we can create database there, we can set permissions. Really easy to use. In this case, we have, for example, this artifact storage. We can check build that was executed like 3 months ago, and, for example, check screenshots, how application looked back then. It may be really useful from business perspective to track this earlier builds. And also 2 things at the end. I really think that cloud is powerful because it allows us to do things easier. We can use services that allows us to just do what we want, not to think about infrastructure that much. And I think that this example is really simple. I mean, it's not that hard to implement using cloud services. And otherwise, we'll have to think about whole infrastructure, manage it. And it would not only require a lot of time, but also it will be quite difficult. And probably we won't achieve results that great. And the second thing is that I think we should think more about the DevOps as a methodology. I mean, this original meaning of this word. it's about cooperation. It's about infrastructure closer to the teams. So it's not like we are QAs and we don't have to care about, for example, infrastructure, or the same in the case of developers. We are all working as a team. We all have to think about it. And in this way, we can achieve something that's really great, that's really useful. In this case, even business people cooperated to create this solution to give some additional requirements, what we need. Developers also contributed, so I think that should be also our goal in most cases. So that would be all. Thanks. And do you have any questions, maybe?
Hello, thank you for your presentation. My name is Mike and I have a question. By the way, in such proof of concept, do you have problems with copy-paste driven development? Because as I see, you can't use parameterization or some tests that use different parameters for the one test.
It's possible to pass any parameters to the specific function, because in this case, maybe I will describe how I adjusted tests that were already available. So basically, I just deployed whole set of the tests to the function. I added tags for every specific test case, so I'm able to select one of them. So I can pass any parameter, like, for example, test case ID or any build-related things to specific Lambda. So it's all on the runner side. And so earlier, I just ran, for example, some Selenium runner for a whole set. This time, I'm doing the same with just one additional difference, that it's just running one set. So from the Lambda perspective, it's running full set with just one test. We can pass any parameters here and from the runner to the function.
So it's just any test? Okay, thank you.
Tomasz, hello. Thank you for your talk. I really like everything connected to Amazon. And I have a question. Could you please tell, are there any technical limitations when we run Selenium inside Lambda, from the Lambda environment point of view?
One of the limitations is the set of browsers we can deploy there, because I used Chrome browser. That's the most popular one, so that was our goal. We are using different services for specific devices, for example. Our goal was to speed up and to get the feedback earlier in any of the supported browsers. So I used Chrome. I haven't tested, for example, Firefox or other browsers, but we have limitations like, for example, max deployment size. So that's why I had to use this workaround with compression and decompression at runtime. There are also a few limitations because AWS recently updated Linux distribution that's at Lambda. So it was AWS Linux earlier in the case of this Python 3.7, for example. But in the case of Python 3.8 runtime, there's AWS Linux 2. And some of the libraries that are needed to run browser are missing there. So we also had to deploy these dependencies separately, these libraries. I implemented the production ready solution that is already used at production in a node, so that was different runtime. But it was possible to implement the same, so I implemented the same twice. There weren't any significant limitations, so probably only the browser set, what browsers are, it's possible to deploy there. And I think
technically, if we have a Chrome browser on our environment and in Lambda, the feature set will be the same. I mean, what we can use there.
Yeah.
Yeah? And one more question. Do you have total pricing for a whole solution? Like you store things, you download, so there are bandwidth payments and so on. Do you have some numbers here?
I just did a very basic calculation for that because I implemented it. It took me like a few months to implement it, to design it fully, and I haven't extended the free tier that's available there. So I ran it like hundreds of times to just check the implementation. So I haven't calculated it, but from my experience, S3 is really cheap, and there isn't a lot of data there. I mean, there are just a few screenshots per build maybe that we store there. But it really depends on the specific implementation, because in this case we just needed like screenshots, some HTTP archives that we upload, and databases also not used that frequently because we are just storing a test state there during execution. So the runner is checking the state every 10 seconds. It's updating its internal state from the database, but we have like 100 tests in our case in production, so it's not a lot of data there.
Okay, thank you.
Thank you.
Thank you for your presentation. Just a quick question. Would you agree that running some lengthy smoke tests or tests with expectations that should wait for something would result in some expenses that aren't that low as you have provided as example?
I provided it for a specific example because it's really difficult to calculate it for some real life cases, but it's definitely way lower than the previous costs we had. I mean, the only thing that it's really important to think about is to set this execution limits properly. So in this case, in real life, we have longest test that lasts about 5 minutes. So we set the limit to 6 minutes. So even if if something in the test isn't working correctly, it will stop. It won't continue the execution. So it's really important to think about things like that. And especially when I developed this runner, there were many bugs or not yet finished things there. So again, these limits were really important to keep the cost low.
Hello, thank you very much for your presentation. That's really interesting solution. Executing like 500 tests in parallel also would apply for application being deployed on some specific environment, because basically it looks like also a performance test, because if you have 1,000 tests in parallel, it also will force you to have additional expenses for a location where you can have this application handling so many requests at the same time. So do you have any problems with that?
Yeah, that was a great thing because during the test execution, they also tested our infrastructure, if it's scaling properly. So we had some problems with slower local environments, for example, that we tried to use. And that's why I implemented an additional functionality in the production tool. So that's the concurrency limit. So it's possible to pass specific parameter, how many instances should be run. So that's the max value. For example, we can run up to 50. So that's enough in our case, or 20. It will still speed up the execution significantly, but won't kill the environment. But yeah, we have to think about infrastructure or application infrastructure too here. But I think it's a great and very easy way to do maybe not performance tests, but to detect any scaling problems. Because sometimes we run like 3 builds in the same time, sometimes we won't run any, and there are just normal users there. And it's a really great test for the infrastructure.
Great, thank you.
Hello, Tomasz, thank you. I have maybe a conceptual question regarding the test pyramid. Why it doesn't fit?
Could you repeat?
Sure. So in the beginning, we were choosing the solution how to speed up the tests. One of the solutions was a test pyramid. Why it doesn't fit?
The test, could you repeat once again? A bit louder? Because it's a really strange sound here.
Okay, I will rephrase. So one of the solutions to have better tests or the better, let's say, test environment is to have test pyramid on the project. It's not about having only end-to-end tests, and it's not only a question how to run them fast. So the other solution could be building a test pyramid where we have unit tests, which actually shows the problem. And they, in the difference with the end-to-end tests, even if they're fast, they won't show the real problem. We can just guess that the problem might be somewhere. So why not to go with test pyramid?
Yeah, we surely have to think about test pyramid because we have to think about different test levels. But in this case, in real life, you have about 100 tests in the current project I work on, and we can't replace these ones. So we also have unit tests, we have some integration tests. There are even more of them than in the end-to-end. But there are some end-to-end tests that we really need because we are checking if we really deliver the business value, if the most important functionalities are working. And we can't skip this one, so we had to speed up the execution of this end-to-end test. And the rest of them is quite fast. I mean, unit tests it takes like 2 or 3 seconds to execute, so it don't make sense to work on it to speed it up because it's already fast. But for us, the problem was that end-to-end tests weren't fast, so that's why we optimized this part. But definitely we need a complete test pyramid. That should be always the goal. If it's possible to check something with low-level tests, then we should do it. But still, there are a lot of things that we can do in this way. And we need also this high-level part.
Okay, thank you.